All right, guys, so please record this on page 8 of your note packets. It's a blank page for us to take a couple quick notes. So the reason we like dot plots or any data representation is because we can describe the data. And so when we're describing our data, I want you to not forget to wear your socks, your S.O.C.S. And so in this video, I'm going to describe to you what S.O.C.S is, or what it stands for. So if you would, at the top of your page, please jot down this dot plot that represents the scores on a math test in a certain class. So just take a second to jot that down, pause the video if you need to, and then we're going to go into what S.O.C.S stands for. And you're going to need the full page of notes for this, so just write, on the smaller side so that you can fit everything. So the first S in S.O.C.S stands for spread. So measures of spread that we've already talked about are standard deviation and range. And so when you describe the spread, you're going to describe how spread out the data is. And so you're going to use words like consistent, or you might say spread out. Or another way to say spread out is to say that the data is varied. So when you describe the spread, you should be describing how spread out it is using those terms. The O in S.O.C.S stands for outliers or any other unusual features. So you're going to want to note what the outliers are. And an unusual feature would be any gaps in the data or any clusters in the data. So for the example at the top of your page, we would note that there's a cluster of points around 81 and 82 because a lot of the data points are clustered there. And we would note that there's a gap in the data between 84 and when we get our next data point at 88. Those are unusual features. So the center of the data we know is the mean, median, and the mode. And so when you describe it, the center of the data, you want to describe the center using the mean or median, and you always explain why you chose that measure. So for instance, this data set of the test scores, I would use the median and I would explain that I'm describing the data set with the median because there is an outlier. And then the last S stands for shape. So there's a couple different shapes that dot plots can take. The first shape is that it could be symmetric. Now the most important thing with symmetric is that it doesn't need to be perfect. So symmetric means that if I fold it in half, that the data matches up approximately. It doesn't have to be perfect. So like in our Google form, the car data wasn't symmetric, it was the SUV, because if you folded it in half, it was approximately a symmetric shape. And so you'll notice that symmetric shapes kind of normally look like a hill if you were to draw a shape around them. Uniform would be that a shape that has, pretty much an equal number of dots in each data value. So this has either 3 or 4 in each data value. So we would call that uniform. Then we have skewed data sets, like the one that we see in our example of the test scores. Skewed data means that the data has some outliers that are causing it to be skewed. The way we decide how it's skewed is if we were to draw kind of a shape around the data, wherever the tail is, and I call this the tail, wherever the tail is, that's the direction that it's skewed in. So if it's skewed right, like it is over here, the tail is going to be to the right. Wherever the tail is, that's the direction it's skewed in. So like for our data with the test scores would be skewed right because the outliers or the tail is to the right of the data. Okay, so I don't want you to copy this. Please do not copy this. But I just want you to see what we'll be doing with this in class tomorrow. We will be writing about the data using S.O.C.S. So here's my example for the data set up at the top. This data measures the test scores on a math test. You always want to start with an introduction explaining what the data is exactly measuring, why it's univariate data. It is spread out, so there's my first S, due to outliers, my O of S.O.C.S, of 88% and 89%. There is a gap in the data from 85% to 87% and a cluster of data points from 81% to 84%. So right there, outlier, gap, and cluster, those are all my O, my outliers or unusual features. The center of the data is at 82.5%, the median of the data set. The median best describes the data due to its outliers. I lastly talk about the shape, the last S of S.O.C.S, saying the data set is skewed right because of the outliers on the upper end of the data. Remember that skewed right is because the tail of the data set is to the right. Wherever the tail is, that's the direction of the skew.